Is machine learning data science? Is machine learning artificial intelligence? Is machine learning statistics? So let me tell you this, it's a Venn diagram. It's not like there is one fits the other. AI and machine learning is very closely related, but AI is far beyond machine learning. Machine learning, as I said, is specifically we talk about learning from historical data to improve performance. But if you see, AI has several other things. It has things like how to do better search, how to do better natural language processing, how do you represent intentions of people in right kind of logic, how do you reason computationally, that's whole notion of logical reasoning, pattern recognition. But if you see, machine learning is a part of AI. It's not necessarily like it is the only part of AI. So don't confuse when people say that AI is about machine learning. So if you see, it's like a Venn diagram. So when I say, when we talk about data science or business analytics, let me give you another perspective here. One is this whole approach of machine learning coming from AI, right? That's where we had new kind of algorithms coming from AI researchers who contribute to machine learning, like decision trees, etc. But machine learning also has roots from classical statistics, where a lot of work in regression models, curve fitting, kind of distance measures between samples, etc., sampling theory, all that comes from classical statistics. So while statistics is made of several things, like it has a broader application in data analysis, but in context of machine learning, statistics contributes some crucial algorithms like regression models, like understanding of distances between samples, etc. So machine learning, if you see, I already have a Venn diagram which is saying machine learning is partly with AI, partly in common with statistics. Same way, in case of data analytics, for handling all the use cases which we talked about, we may be sometimes taking inputs from other areas also, like text mining. Text mining is about when you have large text inputs to you, like text coming from Twitter, text analytics, or text coming from large documents. All of that needs a separate area which is called natural language processing or text mining, which is a huge collection of algorithms which are geared up towards understanding large text corpora. Same way, we can use a lot of work from image mining or image processing, which is very common in large scale analysis for feature recognition in images, fingerprint recognition, video understanding, etc. So image mining, video mining, text mining are separate strands which have come from several other areas in computer science and contributed to data analytics. There's another area which is very interesting, which is coming from the database field of computer science, which is known as data mining. So in fact, there are several database researchers over the last 25 years have contributed to pattern recognition in large databases, which has contributed to latest databases and understanding in latest data analytics. So algorithms like association rule mining, which are part of data mining as part of any machine learning system, actually have roots in databases. The last but not the least is the most hot topic today is what we call as deep learning. Deep learning is coming from its roots in what we call as psychology. It's actually a amalgamation of people from psychology and computer science who came up with this notion of how we can mimic human brain in computers. That's when the early notions of connectionist machines came up, and it was as late as early as in 60s. People started developing this notion of brain-like machines. We call them connectionist machines. And with the recent development in large-scale distributed analysis and large-scale distributed systems, we're able to realize, really true AI systems like the IBM Watson, or the Google, DeepMind, etc. But important thing for all of you is to understand that while all of this is about the different algorithms powering your so-called analytics, whether it is text mining, image mining, video mining, machine learning algorithms, or natural language algorithms, or there is another element is what infrastructure do you run this algorithms on. That's where this whole notion of big data comes in. Big data today is a term given to running large-scale distributed systems on commodity hardware. While we have been running these algorithms, as like I'm sure you are aware of, large-scale simulations for, say, earthquake simulation or weather forecasting have all been running on large supercomputing systems, like the ones in Lawrence Livermore Laboratory, or the ones like in Bluewater, right, large IBM Bluewater system in Urbana-Champaign. Large supercomputing systems, or Cray supercomputing. But it's only in the recent past, about a couple of years back, that we started developing frameworks which allowed even commodity hardware to provide a high performance architecture. And that's where we have inventions like MapReduce and Spark, which enable us to create large scale distributed systems which are cost effective. And that has been the trigger for how we can take machine learning to the masses. Otherwise, machine learning running large-scale algorithms for prediction or analytics on large data, on large historical data, with providing fast response was not so easy. And that's why we had a whole couple of decades of what we call as AI winter, artificial intelligence winter. 70s, a lot of money was pumped into creating machines. In fact, we had Lisp machines which were creating direct hardware to handle some of these artificial intelligence programs. But somewhere there was disillusionment with the outputs, and it took inventions like Hadoop, MapReduce, and inventions like Google Maps, and all the examples of investments done by Google and IBM, etc., to commoditize the large-scale distributed systems, made it in reach of common AI researcher, and today the revolution is for us to see.